everyone. So we are skipping ahead today back to chapter 1 to section 1.4, which is basically about how we count atoms. So before we talk about atoms, we're going to talk about some more familiar objects. So there is a unit of counting that we use to count things like roses and eggs and donuts. And that's a dozen. And everyone knows that 1 dozen is 12, right? So if I have a dozen roses, I have 12 roses. If I have a dozen eggs, I have 12 eggs. That's the most familiar unit of counting. But there are other units too. For example, there's something called a gross. A gross is a dozen. So here is a gross of donuts, right? This is 12 boxes of a dozen donuts. A ream of paper is another unit of counting. A ream of paper is 500 pieces of paper. Okay, so we have all of these numbers. They are not going to be very useful for counting atoms though, because atoms are so small. Even if I had like a handful of atoms, that's going to be like billions upon billions upon billions of atoms. So dozen is not going to cut it for counting atoms and molecules. So instead, we count atoms with something called a mole. So we're going to write down a definition of a mole. And the mole is actually an SI or metric unit of counting. So it's like a dozen, except it's a much bigger number because we use it for counting atoms. So the mole is the SI or metric unit of counting. And it is equal to 6.02 times 10 to the 23rd objects or particles. So you can see why we've been talking about scientific notation, because this number requires scientific notation. Another name for this number is Avogadro's number. So we're going to write down it's also called Avogadro's number. And that's because there was a scientist named Amedeo Avogadro who did a lot of the math with this number. Okay. There's an abbreviation for mole, believe it or not. It's a really short word, but we like to make it even shorter. So we abbreviate it as MOL. He dropped that E. That doesn't seem like much, but it's just really nice to not have to write that E. So we are going to start doing math with a mole, but let me just kind of give you an idea for how big a mole is. So you would never count anything other than atoms or molecules with moles, but if you were to count, say, donuts with moles, a mole of donuts would cover the entire Earth to a depth of 8 kilometers. So that's a lot of donuts. Now, if I had a mole of water molecules, however, that's just about 3.5 teaspoons of water. So that just shows you how tiny molecules are, right? If I can have 6.02 times 10 to the 23rd molecules in just 3.5 teaspoons, that means water molecules are really tiny. So, I'm going to show you a couple of really easy questions. If I ask you how many apples are in a mole of apples, you need to be able to tell me the answer to that. And now you should be able to tell me that there's 6.02 times 10 to the 23rd apples in a mole of apples. Now, what if I wanted to know how many apples are in 2 moles of apples? Well, you guys can probably all figure out. I would just take 6.02 times 10 to the 23rd and multiply that by 2. And if I did that in my calculator, remember for scientific notation, you have to use the capital E. So you do second, capital E, 23 times 2. That's 1.2 times 10 to the 24th. Apples in 2 moles of apples, okay? And then we could do the same thing with like 3 moles of apples. And that's pretty easy. But we're going to be using a lot more complex numbers, so we're going to want to be using Avogadro's number as a conversion factor. So we're going to write down the conversion factor version of Avogadro's number. So if we want to use it as a conversion factor, we're going to write 6.02 times 10 to the 23rd. And we count either molecules or atoms. So sometimes it'll be molecules here, or it could be atoms. It's not both at once, it'll be one or the other. So there are that many molecules or atoms in 1 mole. So here I am abbreviating mole. All right, so last thing we're going to do in the notes is I'm going to show you how we use this conversion factor to solve problems. So, example number 1. I want to know how many molecules are in 0.25 moles of H2O. Okay, so I'm going to set this up just like any other conversion factor type problem. So this number that they gave me right here, that's going to go in the top left corner of my box. I always want to start with what they gave me, or with the given, if you want to call this number the given. Now it's going to be really important that you always include units in these problems. So 0.25 moles of H2O. Okay, I know it seems really tedious to write out the units, especially the H2O, but later on in the year, it's going to become really important that you write both the moles and even the H2O. So we're going to start practicing that right now. Okay, so we want to cross out moles and we want to get to molecules. Now, it's really important that you don't abbreviate molecules or else it will look like moles. And that's really confusing. So just abbreviate moles, not molecules. So I want to use this conversion factor to cross out moles. So I'm going to put 1 mole on the bottom. And that would be 1 mole of H2O because that's the molecule I'm dealing with. In 1 mole of water, or H2O, there are going to be 6.02 times 10 to the 23rd molecules of H2O. There isn't really an abbreviation for molecules, so sorry about that, guys. Our moles of H2O cross out, and then we're just going to put this into our calculator. So we're going to do 0.25 times 6.02 second E23, and we're going to get 1.505 times 10 to the 23rd molecules of H2O. Again, it's very important that you write the units for your answer also. It's not correct unless you've got the units. Okay, I'm going to show you one more example and then we'll be done with the notes. So example number 2, how many moles are in 8.02 times 10 to the 23rd molecules of SF6. Okay, so in this problem they gave us molecules to start with and we're trying to get to moles. So it's kind of backwards from the other problem. So I'm going to leave myself a lot of space in that top left so I can write out this unit. So 8.02 times 10 to the 23rd molecules of SF6 is what they gave me. Now I want to cross out molecules. So that means I'm going to use this conversion factor and I'm going to put the 6.02 times 10 to the 23rd on the bottom because that's what I need to do to cross out molecules. And then I'm trying to get to moles, so I'm going to put 1 mole on the top. So molecules will cross out. Now, if I multiply across the top, I'm going to get 8.02 times 10 to the 23rd moles of SF6. And if I multiply across the bottom, I'm going to get 6.02 times 10 to the 23rd, and there's no unit on the bottom. So I need to divide those numbers. This is where it's very important that you put this in your calculator correctly. So if you have an iPhone or an actual calculator, you're going to use the E button. if you have an Android phone, you're going to want to make sure you put both of these in parentheses. If you don't do that, then your order of operations will get messed up and you'll get the wrong answer. So we're going to do 8.02 E23 divided by 6.02 E23, and I just get 1.3 moles of SF6. Okay, let's see if that makes sense, if we can think about if this answer makes sense. So I know a mole is 6.02 times 10 to the 23rd. 8.02 times 10 to the 23rd, that's pretty close to a mole, it's just a little bit more. So it makes sense that the number of moles in this number would be about 1.33. Okay, if you do this in your calculator wrong, you'll end up getting like 1.33 times 10 to the 46th. If you get that, that means you did something wrong in your calculator, so it didn't know your order of operations. So if you're dividing 10 to the 23rd by 10 to the 23rd, those exponents should pretty much cancel each other out. So you shouldn't get 10 to the 46th if you do that. That's just a common error that people make, so I wanted to point that out. All right, so that's how you use Avogadro's number as a conversion factor. This is a very important section. It comes up on UVU's test for sure, and it's gonna come up later in the year as well. So if this doesn't make sense, make sure you watch this video again or ask me questions, set up a Zoom meeting with me, whatever you need to do to get help. Have a great day.